Everyone, today we're going to look at what a heating and a cooling curve is and how you can tell the difference and what we need these charts and curves for. Okay, so the first thing when you're looking at this, we see something we've been talking about. We see solids and liquids and gases, the three states of matter. Now, if we look at the states of matter and we're in the solid phase, we know that in order to get to the liquid phase, we're going to have to add heat. And as you keep adding heat, those particles gain thermal energy, they start moving faster, and they go through phase changes until you're hot enough to where they're all in the gas phase. Okay, what we do know though is as you add heat, we saw three changes happen. We saw this go from a solid to a liquid and to a gas. So as you add heat, they change, but there is a specific point when a solid becomes a liquid. And there's a specific point where a liquid becomes a gas. And for each substance, that's going to be different. But today we're going to talk about water and what that looks like with water. So, as you see at the bottom of all of your heating and cooling curves, it says heat energy increasing and temperature increasing. And we know that as you add heat, the energy in the particles increases. So, if I am looking at this, in my solid, you can tell that the temperature is at the lowest point down here, and the heat energy is at the lowest point down here. Because solids don't have a whole lot of energy. Their particles are still vibrating tightly, but they don't have a lot of energy. Now, as that temperature goes up, as the heat energy goes up, we see it's going up here. We hit a point, 0 degrees Celsius, where water melts, and if we're going back the other way, freezes. So right here on our heating curve, we heat it up, we heat it up, we heat it up, 0 degrees, we start melting. You'll notice this line is flat. It's flat because at the point where water melts or ice melts, at the melting point, we're going to see two states of matter occur at once. You know, if you have ice in your cup, the ice will not melt immediately. There will be some solid and some liquid here. So in your flat line, that's when we have the phase changes. Temperature stays constant because it takes a little bit for that solid to transform totally into liquid. By the time temperature starts increasing again in your substance, you would see it completely in the liquid phase. So now our substance is completely liquid and our temperature of the substance increases and increases and increases until the substance, in this case water, has an internal temperature of 100. Once it gets to 100 degrees Celsius, we see it start to boil or vaporize. So on this flat line, that's where your phase change is. You're going from a liquid to a gas, the boiling point. So the internal temperature of that water stays 100 degrees until it is completely in the gas phase right here. And then it starts heating up more. And you'll notice this has our highest energy, energy's all the way to the right, and highest temperature. So that's our heating curve. So 0 degrees and 100 degrees are the melting point and the vaporization point in our heating curves. Now, if we went back the other way, let's say we started in the gas phase, we know gas has high temperature and high heat energy. So if we started in the gas phase at our high temperature, we'd notice high energy because this way energy is decreasing. So it's really important you look at these axes. So this is slide 23. We would notice at our high temperature and our high energy, we would be in the gas phase. So you put gas here. All right, and as we decrease the temperature and decrease the temperature, eventually the gas reaches the condensation point. Okay, and condensation point happens. And on the flat line, remember, some of it's a gas and some of it is starting to liquefy. By the time we get here and the temperature of the substance is going to decrease more, you are completely in the liquid phase. All right, and then as we keep decreasing, a liquid becomes a solid. And if you know that, when you put water in the freezer, that's the freezing point, still at 0 degrees Celsius, just like the melting point. Because the point where a liquid becomes a solid is always the same. So you aren't going to use all these words, but if I needed to, and I wanted to add my text here to tell what was happening during the cooling phase, I could say that as temperature decreases and energy decreases, a substance goes from a solid, as the high energy, it goes from a gas to a liquid via condensation. As temperature continues to decrease, the particles lose energy and the liquid freezes to become a solid. Okay, so I just said as temperature goes down and energy goes down, our gases become a liquid and our liquid becomes a solid. The processes here have the same temperature, but remember, on the flat line, that is where our phase changes occur. Okay, this is your heating curve. Remember, at low temperature and low energy, you have to look at these bottom parts. We would have our solid going to our liquid and then our gas. And we know that our freezing point, or our melting point, is where we go from our solid to our liquid. Our ice comes out of the refrigerator and becomes water as it melts. And then vaporization is when your liquid is boiling on the stove to become a gas. Okay, so our solid to our liquid to a gas happens during our phase changes on the flat line because energy is still increasing, but our temperature of our substance is staying the same until it's completely melted or completely vaporized. At the bottom here, I could say as temperature increases, energy increases as the substance changes from a solid to liquid and to a gas. Melting occurs at 0 degrees and vaporization occurs at 100 degrees Celsius. All right, so there we have it. That's what we're going to do today. So you can see in your phase change diagrams, if you read all of this here, you'll notice that when we move from our solid to our liquid to our gas, we are increasing heat energy and the particles are increasing in kinetic energy. But when we go from our gas to our liquid to our solid, we have to cool it down. Temperature is decreasing, energy is decreasing.